To lesson 2, okay, multiplying a polynomial by a monomial. We still have done some of this in Math 9. Okay, in previous courses we've done 2 monomials and a monomial by a binomial or a trinomial, so we're just making it a little bit bigger. So here is, again, I told you that you just have to be able to read algebra tiles. I'm not saying you have to love them and use them all the time, but just understanding what they represent. So this stands for 2. Okay, this is x plus 1. Everything's positive. So when you multiply that, you'll see at the algebra tiles, you get one of those guys, one of those guys, one of those guys, one of those guys, which represents 2x plus 2, which is the same thing as distributing the 2 to the x and the 1. Okay, so they're just setting this up. So this right here is your 2. This is your x plus 1 for multiplication. Okay, so then we have x times x plus 3. So you see how the game changes a little bit. Now we get this big guy, the x squared. Then we get an x, and an x, and an x. So it's x squared plus 3x. Again, you can see that by distributing x squared, 3x. Okay, one more. Now we have negatives involved. So then we have a negative times a positive is a negative x. So I keep that white. All these are going to be white. Okay, negative times a negative is a positive. So these 3 at the end will be dark. Okay, and all these are dark. Okay, so if I go through here and just kind of double check, it's going to be negative 3x plus 3. Distribute, you'll see that's what it comes out because a negative times a negative is a positive. All right. We good? Okay, here we go, last 2. Okay. Okay, so we got 2x times x minus 2. So again, 2x times the x is going to give me 2x squareds. They're both positive, so these are positive x squareds. Then I'm going to get a negative x, negative x, negative x, and a negative x. So I get x squared, 2 of them, minus 4x. 2x times x, 2x squared, 2x times negative 2, negative 4x. All right. All right. Getting the idea there. So this one's going to be 2x squared minus 2x. This is a negative x. It's a negative x. Okay, let's keep going. All right, so each diagram below illustrates the result of the product of a monomial and a binomial. So now we're kind of working backwards. We're just trying to make sure that we can fill out what the diagram is. So like, for example, I would say, okay, in order to get a positive x squared, I have to have an x and an x. So we know those are going to be x's. They could be negative x's. Okay, and then same thing here. Has to be another x. And then this would be a 1. Okay, so that's a negative, so this has to be a negative. These would be positives. And then we have to do the same thing where we would go, okay, let's go negative times a negative for both of these, and that makes this guy positive. That's your other option that you could do to make it true. So for A, I'll just do A up here. See the polynomials it represented. So this would be 2x minus 1 times x. That's the first one. The second one, negative 2x plus 1 times negative x. Okay. Okay, we just did b as well. So complete the left side in top diagram 1, right, as a polynomial as a product. So we just did b and c as well. Right, each product is the sum of difference of two terms. So that's the final product, which would be, was what, 2x minus 1 times x, so it was 2x squared minus x. Verify that there are the polynomial products when x is 3. So I'll let you guys do this. What you're going to do is plug in 3 into the two things I had up here and make sure that they are equivalent. So like I'll plug 3 into this. So that's 9, 18 minus 3 is 15. What was the other one? It was a negative 2x, right? Yeah, negative 2x plus 1 times a negative x. So if I plug that in, it'd be negative 6 plus 1 is negative 5 times a negative 3. Negative 5 times negative 3, also 15. So if you're confused what I'm doing, I'm taking the 3, I'm plugging into my right side that I drew up there that you have in your notes, and then I plugged in the left side. Both of them came out with a 15. Okay. All right, so we'll do this last page here. So distributive property. So distributive property is what we've just been doing, is where you have a monomial outside of a polynomial, or a binomial in this case. You're going to distribute it to both terms. Like that. X times x is x squared plus 3x. Here, 2x squared minus 4x. Distribute again. Negative 3x plus 3. And this one you can distribute that way if you want, or you can hit it with both the other way. Doesn't matter. Okay, these are examples of distributive property. So there's just the rule of distributive property. It's A times B, A times C for this. BA or CA if it's written in reverse. Okay. Use distributive property to determine the following products. Okay, so now we're looking at a couple of things a little bit harder. Like when we get to here, you might be a little confused, but just multiplication is actually the easiest because you just put it together. If they're different like variables, you just slide them together. You don't make a new variable. So like this one's fine, no big deal. 4 times 3 is 12 with the x. 4 times 1 is 4. Okay, with this one, we have an x squared, but still, it's the 2 and the 5 that are getting multiplied. The x squared just stays. Negative 5 times x is a negative 5x. Negative 5 times negative 6 is positive 30. We've got some exponent work here. X cubed times an x squared is an x what? X5, yep. So that's x5, and that's negative 2x squared. Okay, and then here's what I was talking about with different variables. So we're still going to multiply the numbers. So negative 3 times 7 is negative 21. X times x is x squared. We're good with that. Then we have a negative 3 times a negative 2. That's a positive 6. And I have an x and a y, so I write x and a y. They're just all one product. Okay, again, you can't make that any xy squared, nothing like that. It's just xy. And the last one, negative 3 times 1z is a negative 3xz. Okay, in this process, we expand the polynomial expression by using distributive property and the exponent rule of adding exponents, which we did right here. So now, this is where a lot of you might get a little bit confused. Some of you are going to do 6 minus 4 first. Okay, remember, order of operations. We got to push the negative 4 in first. What would you put in? Just a 4? What's that? Okay. Well, what I was saying is that, like, if you did just do a 4, you have a little bit more chance to have a mistake, because if you just do a 4, you have to make sure you have a minus to the bracket of this, which means everything gets hit with a negative anyways. So you might as well just go by a negative 4 now so that it can just be as is. Right, so if we did it by 4, I'll do it by 4 up here. If you do it by 4, you get 6 minus bracket 32x plus 4. So then you have to hit the negative to everything anyways. So you might as well go by negative 4. Okay? So that's what I'm going to do here. So 6 minus 32x minus 4. 6 minus 4 is 2 minus 32x. So this next one, we have 2 to distribute. The 4, 8x minus 12. The negative 2, negative 2x, positive 12. So my 12s cancel, you see that? Negative 12 plus 12. And then 8x minus 2x, simply 6x. Okay. And then back to what Rich was saying, see that negative's there? So all this negative's going to do is going to change the signs of everything on the inside. That's all it's going to do. It's a negative 1. Okay, so this one, 5x times 3x squared, 15, whoops, 15x cubed, negative 35x squared, plus 5x, minus 4x, minus 3x squared. They were positive, now they're both negative. We're going to combine like terms next. We're not done yet. Always have to combine like terms. So I don't have any other cubes, so my 15x cubed is still 15x cubed. It's also good to put them in descending order, like we talked about before. Highest exponent first to lowest. So technically I could put that in front, but it's okay here. It's more when you have stuff like this. Negative 35 and a negative 3 is a negative 38. 5 minus 4 is a 1x. So that would be your solution there after simplifying. Okay, last example here. All right, so determine, and for whatever reason, when these are on tests, you guys freak out about perimeter and area, but that's just an easy way to relate things. So like, for example, so determine the simplified expression of the area given by the shapes, adding areas of the 2 rectangles. So what we got to do is we need to break this into 2 rectangles to do area, because we don't have a formula for this type of rectangle. So we're going to do this one and this one. We're going to add them together. So to do that, we need to figure out, okay, how far is this? Yeah, it's 2x. This is 4, and that's 2 of it. This is the other 2 of it. So now you have your areas. We go 3x plus 2 times the 2x plus x plus 5 times 2x. So we distribute 6x squared plus 4x, 2x squared plus 10x. Now I combine like terms. 6x squared plus 2x squared is 8x squared. 4x plus 10x is 14x. Okay. Okay, subtracting the areas of the 2 rectangles. So now we're same thing. We're going to subtract the area of the 2 rectangles. Why would we do that? Oh, okay. If we subtract them, what's that going to give us? What spot? Gives us the open space. If I take this guy minus this guy, it's going to give me the open hole. How much is left over? Okay? Because I'm taking this whole half, I'm subtracting this, so really what's left is this, which is these are equal, right? So by subtracting, that's what's going to happen. So we're going to do that now. So 6x squared plus 4x minus the whole group. For the whole group, 2x squared plus 10x. So it's minus 2x squared. 6x squared minus 2x squared is 4x squared. 4x minus 10x is negative 6x. So that would be with subtraction. Okay, and that's it for lesson 2.